guys, welcome to your first lesson of Pre-Calc and Trig. I'm so excited to be here. I hope you are too. Okay, so we are starting with prerequisites, which is we're just doing some basic Algebra 1 or Algebra 2 review before we jump into pre-calc, okay? So first we have prerequisite 1, which is going over real numbers. So within this lesson, you're gonna be converting decimal or fractions to decimals, writing inequalities, applying basic, concepts of algebra, and then work with exponents and scientific notation. So let's get started. So first we have talking about representation of what is a real number. Okay, so a real number is any number that can be written as a decimal. So if you have some examples, so like -8, 0, 1.75, 2.3 repeating, 0.36 repeating, 8/5, as long as it can be represented as a decimal, then it is a real number. So we have natural numbers, so like your counting numbers, 1, 2, 3, 4, those are real numbers. Whole numbers has a 0 with it, and your counting numbers. Integers are negative, 0, and positive numbers. These are all examples of some real numbers. And so we have a bunch of stuff here that you can write down. Basically, also we need to talk about if it terminates. So if you have a decimal that terminates, that means that it is rational. If it does not terminate, so like think of pi, 3.1415,926, that is an irrational number because there is no stopping point. It's not a repeating value. And so it does not terminate. But if you think of like 1/3, if you convert that to a decimal, that's 0.333333 repeating, okay? That terminates, or it's, it's infinitely repeating, okay? Or if you think of 1/4, 1/4 written as a decimal is 0.25. It terminates, like it doesn't continue on forever and like has no repeating values, okay? So that's kind of what we're talking about at the beginning of this chapter, is converting decimals and fractions and then determining if they terminate or do not, okay? So then some examples again, if we have determined the decimal form of 1/16, super easy to find. 1/16, that is a fraction that represents division. So 1/16, if you put it in your calculator, is 0.625. It terminates, like it doesn't continue on. So this is the decimal form. And then 55/27, if you put that in your calculator, you get 2.03703. Okay, so if you look, 037,037,037, okay? That repeats, so it's infinitely repeating, so then therefore your repeating would be 2.037. And then we cannot, if we did 1/17, this would be 0.588235294. There is no pattern, nothing is repeating. So it is approximately equal to this, so it doesn't terminate. We cannot find the exact number, okay? So that would be your exact number, is just 1/17. Now let's talk about graphing inequalities. Sorry, that word just slipped my mind. Let's talk about graphing inequalities. In Algebra 1 and Algebra 2, we've done, the open circle and closed circle. That's how we've graphed inequalities. Now we're going to be talking about brackets and parentheses. They have the same concept, either something is included or not included. And so if it's a parentheses, that's the same as an open circle, it's not included. And then if it has a bracket, it's the same as a closed circle and it is included. So here is kind of a unbounded and bounded intervals of real numbers. So again, here, if we have the inequality notation, x is greater than or equal to a, that means it's closed, that means it's included. So at a, it's a bracket, okay? But if we have x is greater than a, that means that it is not included. So it's an open, which is a parentheses, okay? So again, usually, so if we have like a less than or a greater than, we used to do an open circle, okay? Back in Algebra 1, Algebra 2. Now, going into pre-calc and trig, this would be a parentheses okay? Now, if we had a less than or equal to or greater than or equal to, back in Algebra 1 and 2, we did closed circles. Okay, now if we're talking about them being included, we have brackets. So brackets will be the or equal to, and then parentheses are just the less than or greater than. Okay, and then if we have compound, which is we have two things where it's between two numbers, not just one number to infinity or one number to negative infinity. If it's compounded between those two, then you look at, like here we have, both of these are brackets, so that means they're both included. They're both less than or equal to, less than or equal to, so it's the, space in between A and B. Okay, here they're open parentheses, so that means A and B are not included. So it's all the numbers between A and B, but not A and B. Okay, and the same, you could have alternate, like one can be half open and one can be half closed, or like half open, half open. So one can be included and one cannot be included. So like A is included and B is not included. Okay, so these are just kind of different interval notations. I would kind of look at it back to if it's just a less than or just a greater than, then they're in parentheses. If it's a less than or equal to, greater than or equal to, it's included and they are brackets. Okay, let me clear this. Okay, so again, here's some more examples. So converting intervals and inequalities. So here we have a bracket in -6 to 3, which in those are parentheses. So this bracket means this -6 is included, and then this parentheses means this 3 is not included. So if we did this on a number line, okay, so here it kind of says it in words, and then if we represent it by this figure, so at 6, or -6, sorry, it is included, there's a bracket, and then at 3, it is not included, so it's open. And then if we wanted to do the interval as far as, okay, one thing that you get to know about my smart board is I say it's haunted or it has COVID. It just decides to uncalibrate, even though it's calibrated, then it just decides to go all willy-nilly. So, fun fact about that, it's delightful. So this would be the corresponding, as far as like the interval with the inequalities, and this would be your graph, okay? And so here are two more examples. So like negative infinity, obviously negative infinity isn't a number. There's no number to represent it, so it never will be included. And then here it's to -1. So at -1, it's a parentheses, and then it's shaded toward all the negative infinity numbers. And then that would be represented just as x is less than or equal to -1. So that's a super basic one. Okay, so there's some more examples there. I'm gonna erase this. Now let's talk about some exponent properties. So talking about the base and the exponent. So if we have, like here we have in -3 raised to the 5th power, your base is the -3. Your base is what's being raised to the exponent. Okay, so -3 in parentheses raised to the 5th power, your base is -3, and your exponent is 5. But if you look at -3 raised to the 5th power, here your base is 3, because the only thing that's being raised to the exponent is the 5. This would be the same thing as -1 times 3 raised to the 5th power. Okay, so your base here is 3. That negative is just there out there to trick you. So -3 isn't being raised to the 5th power, the 3 is. So this goes with the sec B. And then here we have all the properties of exponents. I would write these down. It's in your Google form or in this Google slide in your Google Classroom, but these are properties that they just come up constantly. And so make sure that you know these and you have these memorized and you can utilize those. So looking at some examples with our properties of the exponents. So if we're here, we're multiplying, we're simplifying using powers. So we have 2 times 5, those are our coefficients. We can multiply those. And so we're multiplying these two things. If we multiply with the same base of A, we add our exponents. So here's a 1, 1 plus 2 is 3. And then here for our B's, we have B to the 3rd times B to the 5th. Same base of B, add our exponents. 3 plus 5 is 8. So then this would be your answer right there. Wow. Okay, another property of exponents is you can't have a negative exponent. So here we have v to the -2 power, and then down here we have u to the -1 power. So in order to get rid of that negative, you switch it from this one, v to the -2, To get rid of that negative, we just moved it to the bottom to say v to the positive 2. The same thing with this u to the negative 1. It's at the bottom as a negative, but if we move it to the top, it becomes a positive. So now we can simplify like they are. These u's, same base, they're being multiplied. We add our exponents. 2 plus 1 is 3. V, add those, we get 5. Okay, these are not similar, so we can't simplify that at all. And lastly, we have a powers to a power x squared over 2. This is being raised to the negative 3 power. Okay, whenever you have a power, you need to, what it first did is it split it up. This negative 3 is being raised to the x squared and to the 2. So that is distributed first. Okay, now we are going to, whenever you have a power, to raise to a power, we multiply. So we multiply negative 3 times 2 to get our negative 6. Okay, so now let's get rid of these negative exponents. You can't have an answer with a negative exponent. So x to the negative 6 power, it goes to the bottom. And then 2 to the negative 3 power, it goes to the top. 2/3 is 8. And then we have x to 6 is just x to 6. So that would be your simplified answer. Okay. So now let's look at scientific notation. Scientific notation, I mean, it's kind of something that you've talked about, you've heard, back in elementary school, you use it. It's kind of like you need a refresher every time. So here's your refresher. So any positive number can be written in scientific notation. So c times 10 to the n power, and then where c is between 1 and 10, okay? So, and m is an integer. So this notation, it provides to work with really small or really big numbers. So like the distance between the Earth and the Sun is 93 million miles, okay? Well, to represent that in scientific notation, we put 9.3, again, it's between 1 and 0, so it's always just gonna be like in the 10th place, so 9.3. And then we have to figure out how many times we moved it. So 1, 2, 3, 4, 5, 6, 7. So this would be a positive 7. Okay, if it's a big number, this is a positive. Okay, but here we have, this is a very small number, 0.0000000000000, like that's super small, and then 53 grams. Okay, so how do we represent this in scientific notation? So we don't have to write 17 million zeros and get confused. So we need to move our decimal. So we have it right here. Hopefully it's kind of calibrated. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It's got to be between 0 and 10, so it'd be 5.3. I moved it 23 places, and so 5.3 times 10 to the negative 23 power, okay? It's a small number, we moved it to the left, so 23 is a negative. Okay, and I think that is, nope, just kidding, that's not it. Okay, so now we have converting to and from scientific notation. So here we have 2.375 times 10 to the 8th power. So this 8, it's positive, so that tells me it's gonna be a big number. So all we do is we take our decimal and we move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. And then each loop you put a 0 in. Okay, so that's 237,500,000. And then B, we have a small number. So that kind of gives us our negative exponent. So we have 0, 1, 2, 3, 4, 5, 6, 7. So we get our negative 7. And then using scientific calculator to simplify this, there is one like this in your homework. It kind of looks like this. So first we convert it into scientific notation, and then we look at these. Okay, so we're gonna take our decimals and we're gonna take our fractions and we're gonna separate them. So 3.6 times 4.5 divided by 1.8 is 9. And then if we have 5 plus 9, since these are the same base, so 5 plus 9 would be 14, minus 4 would be 10. So this would be scientific notation, and this would be expanded. Okay, so that is it for today's lesson. Usually at the end I put how many problems you have. There's 24. I know that's a lot. I promise whenever we get into the pre-calc and trig, it's not going to be that much. But since it's prerequisites, and there's a lot, and they don't take long. It does not take a long time. So today's lesson is 24 questions, but they go by very quickly. So hopefully that helps. If you have any questions, please do not hesitate to email me. I am here for you no matter what question. It can't be too small. I promise I'm here, and we'll get started on P2 tomorrow. Bye.